All right, this is Clinton Weir. I'm talking today about my final project for CSC 535 Deep Learning at the University of Illinois at Springfield, spring 2024. In this project, I have endeavored to create a convolutional neural network for images of latches. These are used to secure doors at a self-storage facility, and the neural network should classify the latches depending on whether they have, what type of lock they have on them, or if they're unlocked, it should classify it based on whether it is zip tied or not. So you got five categories. Discus. Oh, and also, okay, you have discus, which we discussed. Padlocked. It's got a padlock on it. Unlocked and zip tied. Unlocked and no zip tied. And then the one I forgot to mention is if the unit has more than one lock on it. Then if it's got more than one lock on it, then well, that's a problem too. Tenants are not allowed to use more than one lock. Fortunately, the category of multiple locks and the category of no zip tie, unlocked and no zip tie, these two just don't happen very often. If somebody moves out, then we put a zip tie on that unit pretty quick. And if somebody since you're not allowed to have multiple locks on your unit, that typically doesn't happen either. The only exception is that if somebody becomes delinquent on, their account becomes delinquent, then sometimes the management will put a second lock on their unit. So then you would have, that would be another case where you'd have two locks. In fact, that's the reason why we don't allow tenants to have multiple locks on their units, because because we might need to put a second lock on the unit. All right. So now that we've tuned our various parameters, we have found the potentially we found sorry. So now we look at the best model we found. We trained it for 150 epochs, and probably maybe we could have yeah, it looks like it probably was about as good as it was going to get. So we've trained it. Let's see how good it actually was. We evaluate the model on the validation data set. It's 91%, 92% accuracy. Let's evaluate it on the test set. That's data that it hasn't seen yet, and it's 93% accuracy on the test data set. I think I said I wasn't gonna talk about data, but this is the grand conclusion. This is what we've been, all this has been for. So when you evaluate it on the test data set and you build your confusion matrix, like I said, 93% accuracy, and it did good against all of the most important categories. For discus locks, 31 out of 32. In fact, in both axes, for true discus lock images, it recognized 31 out of 32. 31 out of 32 images that it thought were discus locks actually were. For 2 out of 3 latches with multiple locks, not as good. 2 out of 3 is as good as it can be without being perfect. Units that were unlocked, that did not have a zip tie. I'm actually, I think that's right. So it just totally whiffed. It just totally, it didn't predict any units. It did not predict for any units the label unlocked. It just didn't recognize them. Probably because, you can see it. It doesn't recognize between unlocked and zip tied. It just thinks, probably, and it's not surprising, because there were so many more zip tied units than unlocked units. It had a lot of experience with zip tied units and very little experience with unlocked units. And really, there's not that much reason for us to be concerning ourselves with identifying units that are unlocked. Not that much. If a unit is locked and one day, and it's unlocked the next day, or if it's got a zip tie on it the next day, either one is something we want to look at. But we could just lump these, so we could just lump these unlocked unit, we could lump that category in with the zip tied unit. Just call, because those are both, those, if it's zip tied, it is unlocked. So we could lump those together into one category, in which case, the model performed even better than what we just said. 31 plus 2 plus 12 plus 29, that's 74, and there's, so that's 31, 2, 12, 27, and that one. And then there's 1, 2, 3. 74 out of 77. That would be 96%. That would be considered 96% accuracy if we lump the unlocked and the zip tied. And there's justification for doing so. So that would seem like a sensible, reasonable thing to do, and it would, and it's reasonable and sensible that the model would lump these together. It's sensible and reasonable for us to lump them together, and if you do it, it just goes that much further in saying how good this model performed. Whether it's 93.5% and 96%, whatever you want to say for accuracy, and it was good across the board. It wasn't as good at recognizing multiple lock situations. Honestly, though, that too is not our biggest concern. We want to know, is it locked or not? That is the main thing. And, we also kind of want to know, do they have a discus lock or a padlock? But locked or not, number one importance. And in this model can tell locked from unlocked. Look, unlocked. It does not mistake an unlocked latch for a locked one. Perfect. Locked. The model does not recognize it does not misrecognize any locked state for an unlocked state. Every locked unit was recognized in one way or another as a locked unit. So, if you just look at this model from a perspective of locked or not, perfect. It is absolutely perfect. And that might, that is a completely reasonable way to divide the data. It's not what we did. It's not what we, how we designed it. But those are, if you look at it from a binary lens, locked or not, which is completely reasonable to do, then this is a perfect model. It just seems to have performed beyond my wildest dreams. Okay, so then we moved on to display errors. I forget what happened, but it wasn't working out for, there was a function that I wrote that just, I was having trouble with it, one kind, I don't remember what. So I wrote a quick little block of code. We loop over the images and labels in the test data set and display the images and labels for the that were misclassified. This is described as a padlock. This is misclassified as a padlock. I mean to say, and I find that disappointing. I'm not sure what possessed the model to misclassify this one. It doesn't look any more like a padlock than any of the discus locks, any other discus locks. And it's the only one it misclassified. So I don't see it. I don't see why this image should be misclassified. This second one is misclassified as a discus lock, and I totally understand because it's got 2 discus locks on it. This one is classified as zip tied. That one, it's not obvious. This one was as well. Like we said, those were the only 2 images of zip tied units, of unlocked units, and they obviously are not zip tied, but basically what happened, the way I would say it, the model saw a lot of zip tied units and mistook, in my opinion, the model mistook all of the zip tied units for being unlocked. So whereas I am calling the units zip tied, I think the model probably it probably didn't register the zip tie. It registered that there was no lock. I think that's what happened. Is it said, hey, there's no lock on this unit. It didn't find it in the feature map, and so it lumped it into this other category, and that's what I think happened. That's why this unit, this latch, and this latch, it didn't find a lock on it. It didn't find a lock on the zip-tied units. It didn't find a lock on the unlocked units, so it lumped all those together as zip-tied. Now, if I had put in more unlocked latches, maybe it would have lumped them all together under that label. And then this one is labeled multiple, and I don't see it. I don't see why I don't have. This is the most puzzling one now that I think about it, because there were not many. There were very few multi-locked latches. There were very few of them. So, the lesson that we learned just a moment ago from the unlocked zip-tied, not zip-tied, that in that case, the model basically eliminated the unit, the label that was. It just eliminated the label that was underrepresented. In this case, multiple locks. There were so few. You would think it would have obliterated that label as well, rather than putting something that didn't belong into that category. It's puzzling. It's very puzzling. I can't account for this. But we've gone deeper into this, into the details. This is more report stuff that I've gotten into. But maybe it's a little nice to conclude this video series with something more like that resembles a conclusion. Feels appropriate. And so this concludes the video section of my reporting on the final project, my final project for CSC 535 deep learning for at University of Illinois Springfield for spring 2024. Thank you for I can't imagine that anyone has taken the time to watch all these videos, but if you have, heart goes out to you.